This video is on solving rational equations. A rational equation is an equation that contains at least one rational expression. To solve a rational equation, we want to multiply the entire equation by the least common denominator of the rational expressions in the equation. This will eliminate the fractions, resulting in a linear or quadratic equation to solve. You must check your solutions because sometimes the solution to a rational equation is a value that will make the denominator of the rational expression equal to 0. These are called extraneous solutions and must be excluded. Let's take a look at several examples here. Our first one is 2x minus 5 over x minus 2 minus 2 is equal to 3 over x plus 2. So looking at my denominators, I have a denominator of x minus 2, a denominator of 1, and a denominator of x plus 2. So my common denominator would be the expression x minus 2 times x plus 2. So I want to multiply the entire equation by that common denominator. And if you'd like, you can write this over 1 if it helps you to see it better. So I need to multiply each of the three parts of this equation, each of the three terms in this equation, by this common denominator. And what will happen is the denominators in the original equation will cancel out. So for example, when I take the expression 2x minus 5 over x minus 2 and multiply it by x minus 2 times x plus 2, the x minus 2's cancel out, and I'm left with 2x minus 5 times x plus 2. Because the expression x minus 2, the binomial x minus 2, cancels out. Now, distributing to the negative 2, nothing cancels out. So that's going to be negative 2 times x minus 2 times x plus 2. And then distributing to what's to the right of the equal sign, the binomials x plus 2 cancel out, and I'm left with 3 times x minus 2. So now I have a basic equation that does not contain rational expressions. So what I want to do is simplify, go ahead and get rid of all of my parentheses here. So this is going to give me 2x squared. Negative 5x plus 4x is a negative x minus 10. And I know that these two binomials here are x squared minus 4. So multiplying by negative 2 gives me a negative 2x squared plus 8. And that's equal to 3x minus 6. I really like this one because notice I have a 2x squared and a negative 2x squared, so those make a 0 and cancel each other out. And so then I will have negative x minus 2 equals 3x minus 6, and now I have a really nice linear equation to solve. So this gives me, adding x to both sides gives me 4x, adding 6 to each side gives me 4, so x is equal to 1. Now, before I go ahead and box that as my final answer, I want to make sure I check that solution. First, the easiest check is to make sure that if x is equal to 1, are either of my denominators equal to 0? No, they are not. So let's go ahead and check that by plugging it into the original equation here. So is 2 times 1 minus 5 over 1 minus 2 equal to 3 times 1 plus 2. So that's going to give me a negative 3 over negative 1 minus 2. Is that equal to, forgot my question mark, is that equal to 3 over 3, which is 1? So negative 3 over 1 is 3 minus 2 equal to 1. Indeed it is, so my solution is x equals 1. Let's take a look at a second example here. Here we have 1 over x squared minus 5 plus x minus 7 over x equals 4 over x squared minus 5. So I'm going to go ahead and factor this denominator. This factors into an x times x minus 5, as does this one. And so I can see that one denominator is x times x minus 5. My other denominator is x. This is the same as my first one. So my common denominator is going to be that denominator there, x times x minus 5. I'm going to go ahead and cross those out so that we see that that's there. So my common denominator, x times x minus 5, and distributing that 3 times, it completely cancels out the denominator of my first rational expression, so I'm left with 1 plus, and then here the x's cancel out. So I have the x minus 7 that was in the numerator times the x minus 5 that does not cancel out equals, and again my whole denominator cancels out, is equal to 4. So all I have to do here is go ahead and simplify. So let's go ahead and distribute that out. That's going to give me a negative 12x plus 35 equals 4. And here my x squared term does not cancel out, so I'm going to have a quadratic equation to solve. Recall that to solve a quadratic equation, we want to set it equal to 0. So 1 plus 35 gives me 36, and then when I subtract this 4, I'll get 32. And this expression is factorable. If it weren't factorable, I could use the quadratic formula, but this does factor into x minus 4 times x minus 8. So x is equal to 4 and x is equal to 8. A quick check of my original denominator shows me that x cannot be 0 or 5, and I did not get that for either of those, but I do still need to check each one of these. So let's go ahead and check x equals 4. So is 1 over 4 squared is 16, minus 5 times 4 is 20, plus 4 minus 7 gives me negative 3 over 4. Is that equal to 4 over, and then I had 16 minus 20, so is a negative 1/4 plus a negative 3/4 equal to negative 1? Indeed it is, so that does check. So x equals 4 is a possible answer. Now let's check 8. Is 1 over 8 squared is 64, minus 40, plus 1 over 8. Is that equal to 4 over 64 minus 40? Is 1 over 24 plus 1/8 equal to 4 over 24? Oops, 24, not 25. It is, whoops, I wrote it again, because 1/8 is equal to 3 over 24, so that does work. So in this case, both of my answers work. And let's take a look at our last example here, which is going to involve subtraction, which sometimes gets a little bit trickier. Here we have n over 3n plus 6 minus n over 5n plus 10 equals 2/5. So let's go ahead and factor the denominators here. So I can factor a 3 out of this, and that leaves me with n plus 2. I can factor 5 out of this, and that leaves me with n plus 2. So looking at my denominators, I have a 3 and an n plus 2. Here I have a 5 and an n plus 2, and here I have a 5. So my common denominator is going to be a 3 and a 5 and an n plus 2. So let's multiply the whole thing by 3 and a 5 and an n plus 2. So when I distribute to my first rational expression, the 3 and the n plus 2 cancel out, and I'm left with 5 times the n that was originally on top, minus, and then when I do my second one, I will have the 5 and the n plus 2 will cancel it, minus 3n is equal to, and then all that cancels out here is the 5's, 6 times n plus 2. That's the original 2 times the 3. So 2n equals 6n plus 12, become negative 4n equals 12, so n is equal to negative 3. And a quick look shows me that that is not an excluded value, so I'm not going to cancel it or eliminate it automatically, but I'm going to go ahead and check it, plugging in negative 3 for n over, and I think I'm going to go back to my unfactored denominator here, so that's going to give me a negative 9 plus 6 minus negative 3 over negative 15 plus 10. Is that equal to 2/5? And sometimes these can get a little complicated, so feel free to go ahead and use your calculator. So this is going to give me negative 3 over negative 3, which is 1, minus negative 3 over negative 3/5, which gives me 3/5, and 1 minus 3/5 is equal to 2/5. So this one does work. So in this video, we took a look at how to solve rational equations by multiplying the entire equation by the common denominator. This eliminates the fractions, eliminates the rational expressions, and leaves you with either a linear or a quadratic equation to solve. Also, make sure that you always check your solutions, because when you do something like this, you can end up with extraneous solutions or values that don't work or make the denominator equal to 0.